In this lesson, we're going to be making predictions about a population from a sample. By now we know that the results given by a sample are proportional to the results that would be given in a survey by an entire population. If a good sample is taken, it's going to be representative proportionally of the whole population, within a percent or two probably. Here is an example to kind of get us started thinking about this mathematically. A survey asked 72 randomly chosen students if they were going to attend the school play. 12 said yes. Predict the number of students who attend the school if 210 attended the school play. So we've got a few things going on here. 72 students were randomly chosen. That's good. 12 said they were going to go. So 12 out of 72 said yes, I'm going. 72 surveyed, 12 said yes. 12 out of 72, that's 1/6 of those students who said yes. Okay, so 1/6 of the total, okay? But 210 students actually attended the play. So if 210 actually went and 1/6 of the total were going to the play based on this survey, then we can determine approximately, within a few students, probably, how many are in the entire school. So if 210 said yes, how many total? Well, we know, like I said, that 1/6 of the total said they were going to go. So we can say with quite a bit of confidence that 210 is 1/6 of the total, which would be 1/6 times the total. And we know to solve for an equation like this, we would divide by 1/6, which is multiplying by the reciprocal of 1/6. So we would multiply by 6 on both sides. And so by doing that, this gives me 1x. And so 210 times 6 is going to give me 1,260 students. So I can say with quite a bit of confidence that if 1/6 attended, then the number of students in the entire school is probably right around 1,200. Probably not exactly 1,260, but in the ballpark. That's what we're talking about when we're talking about making predictions based on the sample in a survey. Here's another example using a nice little graphic. A guidance counselor randomly surveyed a random sample of 60 out of 900 middle school students. The counselor predicts that 675 students plan to attend college. Do you agree? And why? You're going to have to really be good at explaining and backing up your answers to these questions. In our pie chart, we will notice that the question being asked is, do you plan to attend college? 75% of the students said yes, 20% responded no, and 5% were unsure, and so they answered with maybe. But we're talking here about students who plan to attend college, so we're working with the 75% of the total. Now 60 students were randomly asked this question. So that means 75% of 60 were asked, 75% of 60 responded with yes. So that means that 45 students who were asked said yes, I plan to attend college. Now, 45 of the total, I'm just going to kind of box that in. Now, if I divide 900 by 60, that number is 15. Now, why is that important? Well, if 45 out of 60 responded with yes, then if 900 students attend the middle school, then we can say, using our ratio box and proportional reasoning, we can predict how many students out of 900 attend or plan to attend college. So again, I did 900 divided by 60 is 15. So that means 60 times 15 is 900. Therefore, to find this missing value, I would multiply 45 by 15. And 45 times 15 is 672. So this would be 75% of 900. Is that true? Did I mess up? Let's see. 25. I did. I didn't think that made sense. Excuse me, it's 675. That is definitely right. I knew that 2 wasn't right. So 675 out of 900, that's 75%. Okay? Here's another. A survey asks 48 randomly chosen students if they plan to buy a school newspaper. Of the 48 surveyed, 32 plan to buy a newspaper. So predict the number of students enrolled at the school. So this is kind of like the school play question, where we know how many students purchased the paper, and we know how many surveyed said they were going to purchase out of a total, so we can determine then how many. So 32 said, yes, I'm going to purchase a newspaper. 48 were randomly asked, randomly chosen. So if 360 actually did purchase, then about how many total students are there? Well, I can do this by, again, setting up a ratio box, because we know that these relationships are proportional if the sample represents the population well. And in this case it does, because it's random and it's large, etc. So I set it up just kind of like how I set this up here. And you may be wondering, how do I know that 32 times 11 and 2500ths is 360? Well, I said 32 times what is 360? So I kind of set up a little equation myself. 32 times something is 360. And so when I divide by 32 on both sides to solve for x, I got 11.25. So therefore, 48 times 11.25 will give me a really good approximation of how many students are in the school. It's going to be about how many. Again, it may not be exact, but for the purpose of something like this, it's going to kind of give us a really good picture. So 48 times 11 and 2500ths. 40, 16, that's 20, 9, 10, 9, 0. Again, 20, 8, 9, 10, 4, 5, and 4. So I'm going to add it up over here. 1, 2, 3, 9 and 5 is 14, and 5. And then I had a couple decimal places. So 540 students. And that to me seems reasonable. 540. 540 students attend the school. See, 32 is more than half of 48. 360 is more than half of 540. I feel like that's probably a pretty reasonable answer here. And then lastly, if you ask 75 randomly chosen students how many movies they watch per week, and 21 say they watch one, then how many students watch one movie per week if there are 1,200 students in your school? So keep in mind that these are, again, mathematical estimations based on the appropriate random sample taken. I've mentioned this multiple times because they are proportional relationships. So if you asked 75 students randomly about how many movies they watched and 21 said one movie, then how many students watch one movie a week if there are 2,100 in the school? So I set up a ratio box here. Well, 75 times what is going to give me 200? Well, 75x is 2,100 here. So then I know that x is 28. So that means 75 times 28 equals 2,100. So if I multiply 21 by 28, I'm going to have a pretty good idea about how many students probably watch one movie per week. So 21 times 28, that's 8, 16, 2, 4, 8, 588 students. So I'm confident in saying that about 588 students out of 2,100 watch one movie per week. Yeah, sounds good. That's it.